Hi guys, so in this video we're going to look at combinations, otherwise known as choices or selections. And this is slightly different to what we did in the last video, arrangements or permutations, in where the order was really important. So what we're doing here, it doesn't matter, for example, in a combination or a choice, whether we pick A, B or B, A, they are the same thing. It's just a case of getting the two things that we want. It's a bit like choosing a team of three. It doesn't matter whether I pick Robert first, second, or third, he's still in that team. So if it's, for example, a team of Robert, Brian, and Michael, it doesn't matter what order I choose them, there's still a team of three there. Okay, so a selection of three. Okay, we've met combinations before, very, very early in the course when we looked at the binomial theorem, and I've just written down there the choices, the combinations here. And if you remember that you can put it straight into your calculator, guys, you have an NCR button on your calculator. I think it's above the division sign on your calculator. Okay, so this is just reminding you of the definitions of what NR is. So I think I also told you before that if you look at another book, you might see NCR or NCR be written like that as well. We use the NR notation, and what we're saying is that from N things we are choosing R things. Okay, so for a rugby team, from a squad of 20, that N is equal to 20, my R would be equal to 15 because I need to choose 15 players. Again, order doesn't matter. It doesn't matter if I pick Peter before John or John before Michael. Makes no difference. Okay, so let's have a look at the example one here. It says, in how many ways can 4 different cards be chosen from a standard pack of 52? So again, order doesn't matter. So all I need to worry about here is that there are 52 cards to choose from, and I need 4 cards. Any 4 cards will do. I just need to choose 4 cards from 52. We then stick that into our calculator, and we get the answer of 270,725. Okay, so 270,725. Then states for the second part, says how many of these choices contain the king of diamonds? Okay, so now let's have a think about that. So we still need 4 cards, but one of them needs to be the king of diamonds. So let's think, how many king of diamonds do we actually have in a pack of cards? Well, there is only one king of diamonds, so I'm just going to put KD there for king of diamonds. So there's only one, and we need it. So from that one king of diamonds, I need to choose that king of diamonds. Well, if there's one king of diamonds that we have to have, that means that there's 51 cards left in that deck because the king of diamonds is now already gone. And what we now need is we now need another 3 of them because we need 4 cards altogether. So we need to choose another 3 cards from the 51 that remain in the pack. We just stick it into our calculator, boys, and if we do that, we get 20,825 different ways of having 4 cards that must include the king of diamonds. So just run through that again. We need to have the king of diamonds, so you can see there's one king of diamonds in the pack and we must have it. So therefore, from that one king of diamonds, we must choose it. That means there's 51 left in the pack, and we need to get a further 3, so we need to choose any other 3 cards. Notice that this 51 plus 1 makes 52, which is the number of cards in a deck, and this 1 and 3 make 4, which is what we're trying to choose. Okay, example 2. How many ways can we choose 3 or 4 or 5 cards from a standard pack of cards? Well, this is what we're going to have to break this down. You can see here that this OR, remember, the OR in maths means add. So we're going to have to do 3 sums here. So the first thing we need to do is break it up. So 3 cards plus 4 cards plus 5 cards. And now we're just going to deal with each one separately and add them together. So we need to choose 3 cards from a pack of cards of 52. So this one should be pretty straightforward. It's going to be 52, and we need to choose 3 cards from that. The second one, we need to choose 4 cards from 52 because that's what it says. 4 cards from a standard pack of 52. And the last one then is 52, choose 5. We then get our calculator out and work these things out separately to get 22,100 plus, in this one it's 270,275. We did that in the previous part. And 52 choose 5 is 25,98960. And if we add them together, it's equal to 2891785 different ways of getting either 3 or 4 or 5 cards from a pack of 52. A bit more interesting now, example 3. So example 3 says, how many choices of 4 letters are possible from the letters of the word minerals? How many choices contain 2 vowels and 2 consonants? And how many choices of 4 letters contain at least 1 vowel? Okay, so let's have a look at this. Let's do the first one. So, choices of 4 letters possible from the letters minerals. So let's count out how many we have. Let's say it's choices. As soon as we see the word choices, we know it's choose. So that's the C. And we've got 1, 2, 3, 4, 5, 6, 7, 8. So we're choosing from 8, and we need to choose 4 letters. So it's just 8 choose 4, which is equal to 70 different ways. So that one's nice and straightforward. Next one is, how many choices of 4 letters contain 2 vowels and 2 consonants? Okay, so let's have a look. Vowels and consonants. Okay, how many vowels do we have? Well, we have I and E and A, so we have 3 vowels. And it says we need 2 vowels. We need 2 of them, which means that we need, from those 3 vowels, we need to choose 2. If there's 3 vowels, that means that there must be 5 consonants. And again, from those 5 consonants, we need to choose 2. We then put that into our calculator, and we put that into our calculator, we get 30. Okay, turns out to be 3 times 10. Now notice again that the 3 plus the 5 here, lads, makes 8. So we're choosing from 8, and we're choosing 4, 2 plus 2, we're choosing 4, 4 from the 8. Okay, the last one. How many choices of 4 letters contain at least 1 vowel? So at least 1 vowel. Okay, so that means if we could do this a couple of different ways, so what we're going to do is we could work out at least 1 vowel, so that's 1 vowel, plus 2 vowels, plus 3 vowels. So let's work that out, and if we do that, what we're going to end up with, so for the first one, we've got 3 vowels, I need 1, which means from the remaining 5 consonants, I need 3, plus 2 vowels is 3, choose 2, and from the remaining consonants, I need 2, so it should be a 2, not a 3. And 3 vowels is plus 3, choose 3. And then we have 5, choose 1, because I need 1 of the consonants. Again, just quickly look that this adds up to 8, and this is 8, choose 4. This is 8, choose 4, and 8, choose 4. We can then work them out. And if we do that, we're going to end up with an answer of 65. Now, there's also another way to do this, which will save us a bit of work, and it's actually an easier way to do this. What we can see here, can you see it says here at least 1 vowel? So what we've done is we've said, okay, at least 1 vowel is 1 vowel plus 2 vowels plus 3 vowels. Another way we could think of this, if I do 3 again, just over on the side here, is we could say all the possible ways, so all the answers, so total choices minus 0 vowels. So what we could say here is that let's work out what the total number of choices are, which we've already done in part I, and we can take away the fact that 0 vowels is going to happen here. Now, that means the total choices is just 8, choose 4, which again, as I said, we've already worked out here, minus, well, 0 vowels is equal to, if you have a look at the vowels first, it's going to be 3 vowels, choose 0. And then what you're going to get then is from the consonants 5, choose 4. Now if you work that out, 8 choose 4, we've already done it, it's in part I. That's 70. 3 choose 0 times 5 choose 4 is equal to 5. So that means we're going to get 65 as per the answer down here, and we'd expect them to be the same. So if you see the word at least, it's sometimes or quite often easier to turn around and get the total number of choices, it's what we worked out in part I, and take away the 0 in this particular case. And we're going to use this technique later on in one of the next videos. Okay, the last one here is just working out a bit of algebra with the combinations. So it's asking you to determine the value of n here if n choose 2 is equal to 78. So just if you're not sure, can't remember what the formula is, then n choose r is equal to n factorial over r factorial n minus r factorial. I'm going to just do a little recap on factorials before we attempt this example. Hopefully you can remember if I said to you 4 factorial, that's equal to 4 times 3 times 2 times 1. Remember, we just keep going down and keep multiplying until we get down to 1. Hopefully you can see that 4 factorial is the same as 4 times 3 factorial. And now I'm going to show that 4 factorial is exactly the same as 4 times 3 times 2 factorial, because obviously 3 factorial will be just 3 times 2 times 1, and 2 factorial will be 2 times 1. And I'm going to change it to n, so n factorial is equal to n by n minus 1 by n minus 2, and that'll carry on till it gets down to 1. And we're going to use this idea in the question today. Okay, so in this example, let's go have a look. And it says determine the value of n if n over n choose 2, is equal to 78. So n choose 2, so n choose 2 is equal to, in this particular case, we've got n factorial over r, which is 2, so 2 factorial. We have then n minus r, so that's n minus 2 in a bracket factorial. And we know that that there is equal to 78 because we're told that in the question. N factorial I'm going to change because we said that we can change it. If we have a look here, n factorial can change to n minus 1, n minus 2, etc. as it goes down. So I'm going to change that from n to n minus 1 and n minus 2 factorial. And the reason I've done this is that when you look at the bottom there, you can see that what I have in a bracket is n minus 2 factorial. Now, I can rewrite that 2 factorial as 2 because 2 factorial is just 2 times 1, which is 2. And don't forget, that is still equal to 78. That means now that what we have is we have n minus 2 factorial on both the top and the bottom, which means that they are going to factor or cancel out. And we're going to be left with n minus 1 over 2 is equal to 78. So let's multiply everything by 2 to get rid of that fraction. We get n minus 1 is equal to 78 times 2, which is 156. And then we got n squared minus n, multiply that left-hand bracket, is equal to 156. Get everything across because this is now a quadratic equation. So minus n minus 156 is equal to 0. From here I'm going to factorize. It's going to be n minus 13 and n plus 12. And that's equal to 0, which means I'm going to get n is equal to 13 or n is equal to minus 12. Now remember what n is here, guys. N is what we are choosing from, which means it has to be a positive whole number. It has to be a natural number, in fact, which means that the answer cannot be n is equal to minus 12. It must be equal to 13.